Video lesson 6.3, scale drawings. So when talking about this unit, we were talking about dilations. And if we're looking at this bicycle here, um, these three things that are represented below have been altered with respect to the original image of this first bike. So if you look at the first one, it's as if we took it and we squeezed it vertically, right? We condensed it, if just from the top to the bottom, and we squeezed it in, right? The middle one we can see has been horizontally changed. It's as if I took the left and the right side of the bike and squeezed them together. But the third one, right, it looks exactly the same as the original bicycle, except just smaller. What happens here is in a scale drawing, right, we have a proportional change occur, right? So it's when we're dealing with the dilation, we're going to represent a figure that is just either enlarged or reduced in size from its original. All right. Now we've got a lot of different things that we can do with them. So let's get into what some of those things are and what they will be. So first things first, our scale factor. That is the ratio, which we represent with R, of any length in a scale drawing relation to the corresponding lengths of that original figure. So the R value is the representation of whether we have an enlargement or a reduction, or if the item stays the same. So if we take a look here, when R is greater than 1, right, that means the image size is enlarged. We're going to get a larger picture of what we are talking about. So again, an enlargement. When R is between 0 and 1, aka when it's a fraction less than 1, that's going to represent a reduction. So the size of the image is now reduced to a smaller but proportional figure. The last one is that what happens when R is equal to 1, all right? Technically, this one is not a dilation because the image stays the same, but we do represent that and talk about it as a scale factor. So when the scale factor is 1, no dilation has occurred because the image size has not changed. So when we're talking about dilations and specifically the scale factors, we're talking ultimately about similarity, right? And with that, the most important thing to understand is the two properties that go along with this when doing these types of scale drawings, aka using the scale factor to reduce or enlarge the size. The first one is corresponding angles are equal in measure. I can't stress this one enough. It's really important to know that the angles that correspond to each other do not change, right? No matter how big or small you make the image, if it's a scale drawing, right, aka if it has been dilated proportionally, the angle measures don't change, right? The other property that comes along here is the corresponding lengths are proportional. And this is the part that we're going to see the most here. So corresponding lengths, they are proportional. So that means they're going to either grow or reduce in a ratio that is equal to all of the sides. So let's actually construct a scale drawing here of this first triangle and let's take some notes on how that step process goes. So in order to do this, we're going to need a compass and a straight edge. Again, if you're using a slide compass, your compass and your straight edge are built together. Again, I don't have one of those on this platform, so I'm just going to use a traditional compass. Remember this point, the pointer here, right? This thing here, that's my pointer, right? That would be the bullseye on your slide compass. And again, this is my pencil would be the hole in your slide compass would be the corresponding part for that one. All right, so let's first let's write down some of the steps here as we go. So the first step is determine whether it's an enlargement or a reduction. And that's simply just by looking at what the scale factor is. So in this particular question, right, as I read, they say it's a scale factor of 2, right? So r equals 2, so therefore it's going to be an enlargement. And it does give us a specification that says it has to overlap at A. That means A is not going to move. Everybody else is going to move about A. So in this particular case, right, A will become A prime. So A and A prime are exactly the same location, right? The B and the C points are going to relocate in this process. So step 2, since we now know it's an enlargement, easiest thing that's overlapping, we want to extend the sides of AB and AC. So again, you can take your straight edge, just line them up like so, right? And you can create an extension of that line just by simply doing this, right? Now again, we know it's double the size, so I want to make it a decent size length. You don't have to go super crazy. You can always go back and extend your line if you need to. Again, this doing the ruler for me is not that easy, so I'm just going to use my line tool here. But you can use your straight edge. So now I'm going to do A through B, like so. Again, be as accurate as you possibly can, right? Make sure that pointer is really right on any points that you're talking about. Make sure you line up the sides with the ruler, with the straight edge, as accurately as you possibly can. Again, the more precise you are, the more accurate your picture is going to be, the less likely for mistakes and other issues to occur. All right, so now I extend my lines. Now I actually want to represent this process of, in this case, making a scale factor of 2, aka doubling the size of this figure. So I'm going to start with one of them. It doesn't matter who you start with. I'm going to start with AC. I'm going to put my pointer at A, and I'm going to spin my compass around and move my pencil until I get to the point at C, which is right here. Again, whenever you measure a line segment, you want to represent that you've measured that by just simply making a little arc. So I'm just going to draw a little arc with my compass so that it goes right through point C, and that represents that I've measured it. Right, that little mark there, again, is your work to show that this is what you've done. Now, I want to enlarge this by 2, so I want to double it. So again, a copy is an R value of 1. You haven't changed anything. So this is 1. We now have 1 mark, right? I want R value of 2, so I need a second one. So if I slide down, put my pointer at the mark we just made, again, being as accurate as you possibly can. All right, now I'm going to take my, without changing the size of my compass, I'm going to take my, why does that keep doing that? All right, there we go. I'm going to take my compass. I'm now going to rotate it and just make an arc that intersects the line segment that we've already drawn. So again, this now represents a double the size. So this portion right here, I'm just going to highlight here real quick. This part here represents our value of 1. We've done a second one, so now all of this represents an R value of 2. So I'm going to represent that by simply putting my, naming this point. We're going to name the point right there, and since we moved C, this becomes C prime. Going to do the same thing for B. So again, taking my compass, right, going to put it on A. I'll do this one in green here, right? I'm going to come over here. I'm going to measure to B, make a little arc. Again, be as accurate as you possibly can. Slide down to the mark you just made. Make another arc. That point that you just created, the two intersections of those two things, is now B prime. All right, so let's write in our steps here. So we marked and measured the length of one of the sides. We're going to copy the length of the figure R times. So in this case, doubling. So I'm going to do it twice. So measurement is 1. The second one is 2. So we did that for both C prime and B prime. All right, we're going to repeat that for the other side like we did for B. And last but not least, which I've already done, is we're just going to make sure that we label the new figure using the primes. In this situation, right, A and A prime are the same thing. It is okay if you labeled it, right? This is right here. A and A prime are the same in this particular case. That is not always going to be true, just in this one, because it's overlapping, A and A prime are the same spot. All right, but you can leave it as A. All right, and one last thing that I haven't done yet is I do need to connect them to actually make the figure. So I'm going to do this here by connecting C prime and B prime, and that's going to give me my new figure, A prime, B prime, C prime, which is my new larger triangle. And again, this is a dilation, right? So I have dilated this. I have proportionally changed the size of this. The scale factor is the same for each side. We quote unquote doubled it. So therefore, all of my properties of a scale factor and a scale drawing have been done. So a dilation has occurred. So if I look at this, right, what do we notice about A, B, and A prime, B prime? Right? A prime, B prime is double the size of AB, right? Again, I could say that about any of the sides, right? Any of them have been doubled, right? The angles, right? All of the angles are congruent to themselves. Nothing has changed in the size, right? A and A prime, nothing changed. It's exactly the same angle, right? If I was to go over here and copy, take my take a protractor or something and measure this angle C here, the angle at C prime would be exactly the same. There would be no difference. Again, just because you enlarged or reduced something does not, in a dilation, does not change the size of the angles. It only changes the size of the sides. So we got to make sure we're okay and remember those two properties. All right, so let's look at example number 2. In this question, again, they're telling us to create a scale drawing of the triangle XYZ with a scale factor of R is a half. So R is a half here. So that's going to be a reduction, right? We're going to reduce the size, right? And again, it is overlapping at Y. So that means Y is not going to change. Y and Y prime are going to be the same location. So in this case, when you're reducing, right, all of the other points are getting closer to the point that you are reducing towards. In this case, Y. So to do this, right, when dealing here, we're going to reduce the size of this as a half. So a half, easiest way to do a half is just do a perpendicular bisector, right? So all I'm going to do is create perpendicular bisectors of the line segments that I already have. So I don't have to extend the lines here because X is going to get closer to Y, so I'm just getting smaller, and same thing for Z. So I'm going to go here. So I'm going to put my pointer on Y, right? I'm going to kind of go over here. I'm going to extend this. Again, as long as you go more than halfway, right? More than halfway. You don't have to get all the way to X, though you can if your compass allows you. In mine, it does not. But as long as you go more than halfway, that's enough, right? Go more than halfway. I'm going to put a mark above and then a mark below. I'm going to flip my compass and do the same thing from the other point, in this case X. Again, I'm not changing the size of my compass. I'm putting my pointer on X. I'm rotating it up here. I'm going to make a mark above, and I'm going to make a mark below. All right, I'm looking for where they intersect. Now, notice above they intersected, below they did not. That just means I didn't make my arc big enough, so if you have to, just simply go back, put your pointer on Y. I'm just going to rotate this back out. Just extend that arc until they actually intersect. Sometimes it happens, right? It's no big deal. We just go back and extend it, right? So again, I don't need to actually draw the perpendicular bisector. I'm just looking for where it actually intersects. So I'm going to represent that here with a dotted line. You can just take your straight edge and just line them up, right? So if I just connect those two using my straight edge, again, I want to be as accurate as I possibly can. So there we go. Where that line intersects the side of my figure, so in this case, it would be right here. This would now be x prime. All right, again, I don't have to draw that line segment, which is why I'm doing it as a dotted line. But again, having the arcs like up here and below, above and below, and the point that it intersects is enough to show the whole construction. If you want, put the line segment, that's fine. Again, it does end up a lot of times being a little bit crowded of an image. A lot of people like to just kind of maybe, draw the line segment just where it crosses, like so, with the arcs. Again, all of this is okay. This shows that you have done that full construction. All right, so let's do that again. I know it's something we haven't done in a while, that perpendicular bisector. So let's make sure that we can do it with no problems. So we're going to do, again, we're going to do the same thing. We're going to repeat this process for Z. We're going to put our pointer at Y. Again, we're going to extend more than halfway. Right, more than halfway. So all the way to Z is fine, but again, as long as you go more than halfway, you're good. I'll do this one in green. Again, we're going to make an arc above the line segment. We're going to make an arc below the line segment. Then we're going to flip it, do the same thing from Z. Again, put your pointer on there as accurately as you possibly can. Make an arc above so they intersect. Make an arc below so they intersect. Again, using my straight edge, I'm going to connect those. So I'm just going to show that with a dotted line. There we go. Again, where does it intersect? It intersects right here. At that point, that's my new Z, aka Z prime. All right, so now if I take my straight edge and I connect X prime and Y prime, X prime and Z prime, right, I will now have created a smaller triangle. And I like to shade them in. I know I didn't do it on the other one, but I do like to shade them in. I think shading it kind of helps to see it a little bit better. So I'm just going to shade this in real quick. Just lightly shade it in, right? Just to kind of help show and really kind of make everything stand out. So it's easy to indicate and see here what we got, right? Just like before, okay, this is a dilation, specifically a reduction, right? So if you're looking at the statements I have below, right, x, y, and x prime, y prime, those are sides, right, of the dilation. Those are going to be proportional, right? In this case, by a half. So x prime, y prime is half the size of xy, right? It's also parallel, remember? So again, it's going to be a parallel situation all the time, right? They're either going to be the same line or they're going to be parallel when a dilation has occurred, right? And the other thing we said is about the angles. So Z and Z prime, those would be equal angles. Those would be congruent. Again, all the angles never change when you're performing a dilation. All right, last but not least, we've got example 3 here. So we're going to do another scale drawing. Now, in this case, part of the drawing has been done for you, but they don't give you a scale factor. So you have to determine what that scale factor is. So here, so the scale factor, right, or our R value, right, in order to do this one properly, we want to always follow this concept. We want to do the image over the pre-image, right? Or a lot of you, I know we've talked about it before, you might want to call it new over old, whichever verb you want to think about it, same thing. But image over pre-image is the formal way, or new over old. So, so again, the image is the result, the pre-image is what you started with. So if I look at this, right, I'm going to take my compass here, and I'm going to go here. So they gave me A prime, C prime, so that means it came from AC. So I'm going to go over here, I'm going to measure AC, and we're going to start off by just measuring it. Right, so there's my measurement. Again, we use a little mark to show that. And then I'm going to go see, well, I'm hoping that if I just measure it, and then I go over to A prime, C prime, I see how many times this lands to make A prime, C prime. You know, in a perfect world, it's just going to be an exact match from here. So there's 1. If I slide down, there's 2. So that means that A prime, C prime is double the size, right? Or another way of saying that is my image, it took 2 of these to make the image, and it was 1 to start. Now, again, we hope that it's going to be a 1. It doesn't have to be. Like, I might have to break AC up into 2 parts and then say, well, it's 2 of those, and how many of those were made to make A prime, C prime. Like, it might be like 5 over 2 or something like that. You know, whatever the numbers are, they are. Again, we're hoping for that bottom number to be a 1 because it does make it a little bit easier, but again, it doesn't have to be. But now we know our scale factor here is 2. So now we're just going to perform the same operations as prior. So easiest thing to do in this case, right? I can't just extend the lines like we did in example number 1 because there's nothing overlapping. So I do have to copy an angle here, right? All you have to do is copy one of them for here, and then we can perform the actual dilation. So it doesn't matter, pick A or C, it really doesn't matter. I'm gonna pick A here. So again, to perform an angle copy, I'll do it here in purple. All right, we're gonna make an arc that intersects the angle. So in 2 spots, so those 2 spots. I'm gonna, without changing the size of my compass, I'm gonna go over to A prime and make the same size arc from A prime. So there's my arc, right? So again, it's the same distance away from A and A prime, or that arc is the same distance away from both of those things, right? Now I want to measure. We have this spot, right? We have the corresponding spot right here on the A prime scenario. I got to figure out where is this spot, the second spot, where over here is that, right? That's what I'm looking for. So how do I find that? Again, you don't have to draw this. I'm going to do it in this dotted line, right? I just got to measure that distance, right? So if I take my compass, right, put it on this one endpoint here, go to my second endpoint, make an arc. That shows I've measured it. Now if I slide over, right, again, I'm matching up. So this point here matches up with this point here, right? So now if I make, again, without changing the size of my compass, if I make an arc, we just now made this point, which I have in green, match up to where it's located over here. So now if I take my straight edge, I draw a line from A prime through that point, right? That gives me a copied angle from A to A prime. So those 2 angles are exactly the same. So now that I have that angle copy, all I have to do is just now perform my scale factor process. So again, let's do that I'll do it in red here. So we know it's an R value of 2. So I'm going to go to A, B and measure it because we want to find out where is B prime. All right, so there's that measurement. We come over to A prime. We make once. Do it again for 2. Again, being as accurate as we possibly can. There's 2. So this is now going to be B prime. So if I take my straight edge, I don't have to duplicate this process at C, though you could, right? I could just do this again and see where the lines intersect, right? But since I found B, all I got to do is now just connect C prime through B prime. And that is going to, in fact, give me a triangle that is twice the size of that original. And again, notice Couple things. If you want to check your answer, you can use the protractor. You can check your angles. They should all be exactly the same from the original. So A and A prime should match up. C and C prime should be the same. B and B prime should be the same. The other thing is you could use your ruler to measure, right? AC and A prime C prime, right? This should be double the size of AC, and A prime B prime should be double the size of AB, and vice versa. Um, Again, you cannot use your ruler though to do the construction. You will not get credit for it. You need to have all of these construction marks in order to get credit for the construction process. All right. The other thing visually that I like, again, I'm just going to highlight this real quick just for you to see. Again, when you're doing the dilations, if you guys remember from back from earlier in the year, again, these lines will be parallel to each other, right? So will these two, right? Those would be parallels, right? And so will these should be parallel to each other, right? So again, visually, it helps to see that to help, does that look like they are? Kind of helps to know that if you've done it correctly. All right. All right. So I know this is a bit of a long video, so do take time to kind of go back over it, look over things, practice these again, try them again if you need to. These are 3 different types of constructions for dealing with scale factors. Again, these are not the only ones that can be done. Obviously, the R value could have been bigger, like 3, 4, or 5. Reduction, again, we try, usually it's in like a half or a quarter, something like that. But any of those are technically possible.